This is an ancient alien object that is rapidly approaching our Sun. And for the past month, all of Earth's most powerful telescopes have been pointed at this one strange light in the sky. They've been looking for answers, but what they saw has only raised more questions. Now, time is running out. Soon this object will disappear from our view, hidden behind the blinding light of our Sun, which leaves us with a mystery to solve, a mystery the mainstream media has completely ignored. What is this thing? And why is no one talking about how impossibly weird it is? Officially, it's known as 3IATLAS. The 3I means Third Interstellar Object, the third visitor from beyond our solar system that we've ever detected. It comes from out there, from one of those distant stars you see in the night sky. We're not sure which one exactly, but we're pretty sure that 3IATLAS comes from a very old place in our Milky Way galaxy, from a distant solar system that could be twice the age of our own Sun. This is only the third time we've been able to spot one of these interstellar visitors. The first was Oumuamua, that crazy cigar-shaped rock that came tumbling into our solar system in 2017. We still don't really know what that thing was, but we know it was weird. And it's already looking like 3IATLAS could be even weirder. Then there was 2I Borisov, which has become the underappreciated middle child of the bunch. And that's because it was decidedly less weird. Borisov looked like a comet, acted like a comet, and that's almost certainly what it was. But a comet that came here from another star, which is still pretty cool. But 3IATLAS has quickly become our best opportunity yet to study a genuinely strange alien object. And this is one of those situations where the more we learn, the weirder it gets. The more data we collect, the less sense any of it makes. Let me show you why scientists are quietly freaking out about this thing. Officially, the object was spotted for the first time on July 1, 2025, by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, hence the name. At that time, it was between the orbits of Jupiter and Mars, but still much closer to Jupiter. Although, since then, we've learned that 3IATLAS was actually seen for the first time, back on May 7, 2025, by the Transiting Exoplanet Survey Satellite, also known as TESS. But TESS was busy looking for distant alien planets at the time, so it didn't notice our new visitor. The object just appeared as a dot of light that moved between frames, unremarkable, unnoticed, ignored. When that first image was taken, the object was still traveling between Saturn and Jupiter. That also helps give us an idea of just how fast this thing is moving. When NASA launched the Voyager probes on a direct course for Jupiter in the 1970s, it took between 18 and 23 months to reach the planet's orbit. We know that 3IATLAS was near Saturn in May. It passed Jupiter by July. Now it's passing Mars in September, and will reach the Sun for its closest approach on October 29th. Then, it will be back out at Jupiter's orbit again by next spring. That incredible speed is how we know for sure this is an interstellar object. It's traveling way too fast to be captured by the Sun's gravity, what astronomers call a hyperbolic trajectory. It's not going into orbit, it's passing through. It came from somewhere else, and it's going somewhere else. We just happened to be here when it stopped by. Let's put that speed into perspective. 3IATLAS crossed from the orbit of Saturn to the orbit of Mars in about 4 months. That's a distance of roughly 800 million kilometers. In 4 months. The fastest spacecraft humanity has ever built, the Parker Solar Probe, maxes out at about 700,000 kilometers per hour when it's falling toward the Sun. 3IATLAS is maintaining speeds in that same ballpark, but it's not falling toward anything. It's flying through interstellar space under its own momentum. Whatever star system this object came from, it got thrown out with incredible velocity. Either it was flung out by a close encounter with a massive planet, or it was expelled from a binary star system, or something else gave it that push. And that's our first hint that something about this object is unusual. Now, here's what's interesting about that early observation made by TESS. Even when 3I/ATLAS was out beyond the orbit of Jupiter, nearly 800 million kilometers from the Sun, it was already looking very bright. And then it got much brighter over the 3-week period that TESS was able to observe it. That is weird. Or it's weird compared to the comets we're used to seeing. Typically, comets are big chunks of frozen water mixed up with various rocks, dust, gases, and organic compounds frozen solid out at the edge of the solar system. As that chunk of ice starts getting closer to the Sun, it warms up and begins to melt. Actually, in the vacuum of space, this process is technically known as sublimation because liquid can't exist in a vacuum. The ice goes directly from solid to gas. This sublimation creates the characteristic coma, the fuzzy cloud of gas and dust surrounding the comet's nucleus. And that's what makes comets bright and visible from Earth. But here's the thing. Water ice doesn't sublimate at Jupiter's distance. It's too cold. The Sun's heat at that distance is just too weak. Normal water ice comets don't start to really brighten up and develop their comas until they get much closer, around Mars's orbit or closer. But 3I/ATLAS was bright beyond Jupiter. That means it's not sublimating water. It's sublimating something else, something that turns to gas at much lower temperatures. Already, we're dealing with something that doesn't fit the standard comet model. As 3I/ATLAS got closer to the Sun and more telescopes locked onto it, astronomers noticed something else that made no sense. Its tail was pointing the wrong way. Let me explain. Comet tails always point away from the Sun. Always. That's because the solar wind, a constant stream of charged particles blasting out from the Sun, pushes the gas and dust in the coma away from the nucleus, creating a tail that streams behind the comet, like hair blowing in the wind. You can think of it like this. Imagine a dog sticking its head out of a car window. The wind pushes its fur backward, away from the direction of motion. That's what happens to comets. Except 3I/ATLAS's tail appeared to be forming toward the Sun. Not away from it, toward it. That's like the dog sticking its head out the window and its face stretching forward instead of its ears blowing back. It's physically wrong. It violates our understanding of how solar wind interacts with cometary material. Unless the tail isn't actually a tail. Unless we're seeing some other phenomenon, some kind of outgassing or material ejection that's fighting against the solar wind, or something that's not affected by the solar wind at all. As more powerful instruments turned their attention to 3I/ATLAS, including the James Webb Space Telescope and the Very Large Telescope in Chile, they started analyzing the composition of that massive growing coma. And what they found was shocking. The coma around 3I/ATLAS is enormous, roughly 300,000 kilometers in radius. That's nearly the distance from Earth to the Moon. And it's composed almost entirely of carbon dioxide, not water vapor. Carbon dioxide. The ratio is staggering, about 8 parts carbon dioxide to 1 part water. That's completely inverted from what we see in comets from our solar system, which are typically 80–90% water ice with just traces of CO2, methane, and other volatiles. Finding a comet that's 80% carbon dioxide is like finding a human whose body is 80% bone and only 20% everything else. It's backward. It's wrong. It suggests that this object formed in a completely different environment with completely different chemistry, which makes sense if it comes from another star system. Different stars have different compositions. Different protoplanetary disks form different ratios of compounds. An old star system, one twice the age of our Sun, would have dramatically different chemistry than the solar system we know. But here's the problem. We've never seen anything like this before. We have no comparison. We're looking at alien chemistry, literally materials from an alien world, and trying to make sense of it with our very limited experience of what normal looks like. And then things got really weird. The Very Large Telescope detected something in the spectral analysis of 3I-ATLAS that shouldn't exist. Nickel. Nickel in the coma, outgassing from the object. Now, finding metal in a comet isn't that unusual. Comets contain all sorts of materials, including trace metals. But here's the problem. They found nickel without iron. In nature, nickel and iron are always found together. Always. They form together in the cores of massive stars during supernova explosions. When those stars explode, they seed the galaxy with these heavy elements in very specific ratios. Everywhere we look in the universe, in asteroids, in planets, in other comets, in interstellar dust, nickel and iron come as a package deal. Finding them separated is like finding hydrogen without oxygen in water. It doesn't happen naturally. You need an industrial process to separate them. You need refinement. You need technology. The only known processes that can separate nickel from iron are industrial metallurgy techniques developed by humans. Smelting, electrochemical separation, manufacturing processes. So either 3I-ATLAS contains a naturally occurring separation process that we've never seen anywhere else in the universe, or we're looking at something that was manufactured. Let's be very clear. No one in the scientific community is saying definitively that 3I-ATLAS is an alien spacecraft. That would be career suicide without extraordinary evidence. But here's what they are saying. The data doesn't match any natural phenomenon we've ever observed. So let's walk through the possibilities that scientists are quietly discussing in conference rooms and academic papers with very careful language. Theory 1. The alien probe. What if 3I-ATLAS is an artificial probe sent from another civilization? The early brightness could be explained if the object has reflective surfaces or active light sources. The separated nickel could be structural materials. The massive CO2 coma could be propellant exhaust or waste products being vented as the probe adjusts its trajectory. Theory 2. The interstellar arc. What if it's not a probe, but a spacecraft, a massive vessel traveling between stars? The CO2 could be biological waste being dumped as it passes through our system. The brightness could be reflected sunlight off a massive hull. The speed could be the result of propulsion systems we don't understand. Theory 3. The space organism. This is the wildest theory, but some scientists have proposed it. What if 3I-ATLAS is biological? Some kind of massive organism that lives in the vacuum of space, consuming dust and particles, exhaling CO2, and traveling between star systems over millions of years. Now, here's the critical thing that legitimate scientists keep emphasizing. We cannot say with 100% certainty that this is not an artificial object. They can't rule it out. The data won't let them. Here's where things get exciting, and here's why the lack of mainstream media coverage is so frustrating. On October 29, 2025, just weeks from now, 3I-ATLAS will make its closest approach to the Sun and then begin its outward journey. But before it disappears behind the Sun's glare, it's going to pass relatively close to Mars. About 28 million kilometers from Mars, to be precise. That might sound far, but in cosmic terms, that's practically a close encounter. And we have multiple spacecraft orbiting Mars right now. NASA's MAVEN and Mars Reconnaissance Orbiter, ESA's Mars Express, and Trace Gas Orbiter. These orbiters are equipped with high-resolution cameras, and scientists are planning to turn those cameras toward 3IATLAS during the flyby to try to image the nucleus, the solid core of the object beneath the massive gas cloud. If they can get a clear image, they might be able to determine the shape. Is it a lumpy, irregular chunk of rock like a normal comet? Or is it geometric, spherical, cylindrical? Is it natural or manufactured? This is our best chance to see the object directly before it vanishes behind the Sun. After 3IATLAS passes the Sun and emerges from behind its glare in December 2025, it will be speeding back out toward the outer solar system. And by March 2026, it will pass near Jupiter on its way out of our solar system forever. And that's where things get really interesting. NASA's Juno spacecraft has been orbiting Jupiter since 2016, studying the gas giant's atmosphere, magnetic field, and moons. The mission was supposed to end years ago, with Juno making a controlled crash into Jupiter's atmosphere to avoid contaminating Europa. But Juno is still functioning, still collecting data. And some scientists have proposed a radical idea. What if instead of crashing into Jupiter, we redirect Juno to intercept 3IATLAS? It would be a one-way trip. Juno doesn't have enough fuel to slow down, match trajectory, and then return to Jupiter. It would be a suicide mission, but a suicide mission that could give us a close-up view of an interstellar object. We could image it from kilometers away instead of millions of kilometers. We could analyze its composition directly. We could potentially answer the question that's been haunting astronomers for months. What the hell is this thing? So why isn't the mainstream media covering this story? Why is one of the most significant astronomical discoveries of the decade being ignored? Maybe it's because the data is too complex. Maybe it's because scientists are being very careful not to overhype the alien angle without definitive proof. Maybe it's because a story that says, "We found something weird and we're not sure what it is," doesn't generate the same clicks as a story that says, "Aliens confirmed." But the facts speak for themselves. 3IATLAS is brighter than it should be. Its tail points the wrong direction. Its chemistry is completely inverted from normal comets. It contains separated metals that don't occur naturally. No natural process we know of explains all of these anomalies. We're looking at something that challenges our understanding of cometary science. Something that might be natural but operates on principles we don't understand. Or something that might not be natural at all. And in a few weeks, during the Mars flyby, we might get our first clear look at it. The truth is out there. Literally out there, heading toward the Sun at hundreds of thousands of kilometers per hour. And for once, we actually have a chance to catch it before it disappears forever. Stay tuned, this story is far from over.